It's been 5 years since British Columbia experienced the hottest temperatures ever recorded in Canadian history. For 6 brutal days, an unprecedented heat dome cooked the air over the province. Daytime highs spiked into the high 40s, nighttimes offering little relief. At the peak on June 29th, the village of Lytton hit 49.6 degrees, a temperature hotter than anything ever recorded in the history of Europe or South America. 619 people died. But the human toll was only part of the story. An estimated 1 billion intertidal animals cooked to death on the rocks in a single week. Millions of trees turned a ghostly orange. Across the province, entire ecosystems were subjected to a preview at what happens when the climate changes faster than nature can adapt. Because 5 years later, the data is revealing something unexpected. Some ecosystems are still collapsing, some fundamentally altered, and others have found ways to adapt and thrive. Much of what we now know comes down to a landmark 5-year synthesis study published this spring in Nature, Ecology and Evolution. Scientists tracked the shockwaves across the entire biological spectrum, everything from native bees to baby birds. But some of the most volatile winners and losers were found right on the coast. Let's start with the intertidal zone. To understand why the coast took such a hit, we have to look at the clock. In late June 2021, the heat dome perfectly coincided with the lowest low tides of the year, happening right at solar noon, leaving billions of blue mussels and acorn barnacles exposed to direct sunlight during the hottest hours of the day. Those creatures that could retreat to shade like crabs and fish fared better, but the mussels were cooked alive in their own shells.
The biggest difference was the smell, because so many, like this type of rock would have been covered with barnacles and mussels, and there's a few growing on it now. But when all of those animals died, just that horrible stink of, like the back alley where the trash has been waiting to be picked up for too long. Our current calculation is somewhere on the order of 10 billion barnacles and another 2 or 3 billion mussels. And that's just the Strait of Georgia, so it doesn't include Washington State or places further north. It was a real catastrophe for the marine ecosystem on the shore.
But if you walk these same beaches today, 5 years later, low tide looks full again. Seaweeds are back, kelp blankets the low shore, and the purple starfish are so massive, we know they're old enough to be the same ones that survived 2021. But look closer, and the blue mussels are missing.
There's a few of the barnacles that it's eaten recently.
Part of this is a seasonal cycle, a temporary boom in predatory purple starfish, gorging on the young mussels trying to rebuild a foothold. But with climate change, our native blue mussels are struggling to recover from the heat dome while being actively pushed out by a hardier, non-native newcomer, the oyster.
The mussels just don't tolerate the heat very well. The Pacific oyster, which has been introduced, actually can survive an extra 10 degrees of heat, and they mostly sailed through the heat wave just fine. So I think we're going to tip into a new system where we have a lot more oysters than we used to.
We're seeing that same rewriting of the landscape here in our forests. When the heat dome hit, the internal temperature of needles and leaves pushed past 50 degrees, essentially destroying the chlorophyll. But trees play a much longer, darker game than marine life. They don't always die right away.
Most times when trees die, it's a matter of compounding stresses. Orange is the first stage of death.
Yeah.
So when they turn orange, we know that they're going to turn red, then brown, then all the foliage will fall off.
Plants rely on a continuous network of internal pipes to pull water all the way up from the soil to the leaves. But during the heat dome, that system snapped, introducing pockets of air directly into the pipes, like a structural stroke for a tree. 5 years later, arborists are still dealing with delayed mortality. These are trees that looked like they survived 2021, but then spent the last few years starving for water, leaving them wide open to the secondary bark beetle attacks and fungal infections killing them today. But the biggest surprise in the data, there were some winners that emerged from the heat.
We sort of envision the heat dome as being kind of universally negative for plants. But what we actually found was that depending on where the plants were growing, the impacts of the heat dome could actually be negative or positive. And so plants that were growing in kind of drier, hotter areas tended to suffer negative impacts of the heat dome, while plants that were growing in wetter, cooler areas actually improved their performance.
Turns out the heat dome actually pushed some cooler, high-elevation mountain forests right into their preferred peak temperature zones for photosynthesis. And if a plant had direct access to water, like in coastal wetlands, it used that water to sweat, evaporating moisture through its leaves to cool down. Finding those pockets of survival required a level of cross-disciplinary teamwork never before attempted in this scientific community. When the heat dome broke, researchers from across the Pacific Northwest rushed to pool their raw field notes before the evidence washed it away. 5 years later, those same scientists say they're now connected for life, a rapid response network ready to deploy the second the next climate shock hits. Because as the data warns, time is running out.
These events are predicted to increase in frequency and magnitude and duration in the future. By the middle of this century, events like that are forecasted to occur every 5 to 10 years. The results of this study are more important now than they have ever been in the past.
The 2021 heat dome left a permanent footprint on British Columbia. It serves as a living laboratory, a litmus test for our future, proving that survival in a changing world is about who can find the shade, who can access the water, and who can adapt before the next wave hits.